Now it is time to start working with the bottle inside the melon. We will fill the bottle with Glu3D particles. But before coming to this point, I want to talk about management of the objects in the scene. As our project develops, we can see that it is becoming very crowded. We have many lights, a lot of objects, orange, melon, bottle, particles around them, pea wrappers. So our scene is too crowded to work. Now we will add a Glu3D node, and this will make the scene more crowded and more heavy. So at this point we have to manage these objects and hide some of them. In this kind of crowded scenes, I use layers to manage the objects. Here is the layer manager, and you can see I have already created a lot of layers to store these objects, and now I will hide most of the objects, and we will work only on the bottle collide object. Now I want to show you which layer contains which objects. For example, lights layer is for all the lights, and I will hide them. Static particles layer is for all particles created with particle flow and the pea wrappers, so we don't need them. I will hide them. And what else? I will hide orange scene objects. They are high polygon orange objects. We don't need them. And at this time we also don't need the orange collision objects, and also we do not need the animation dummies. I'm using them for animations. I'm hiding them. And we do not need to see a bottle scene object. It is another high polygon object. We do not need to see the cap of the bottle. And what else? We have the melon here. We do not need melon object. Yes. We will just here is our bottle. To fill an object, it must be a closed object, and our bottle is also a closed object. So now let's add a Glu3D node. Let's see it. Here is the Glu3D node. And how we start? First of all, I have to add this object to Glu3D object manager, and I will set per object attributes. First of all, I will click on add selection to list button. I will set bounce parameter to 0 and adherence parameter to 0. Before simulation starts, I will come back here and reset them. But before filling the object, we have to set all these parameters to 0. Now I will close it. So let's start filling the container. First select source, Glu3D source, and set these source parameters. I will set only thickness to 2.5, level of detail 6 is okay for me, and radius and rate, and we do not need to set radius and rate parameters now because we will not use them. And select object field. Particles. Here are the particles. Yes, here are the particles. Now we have 1503 particles. Maybe we can have a bit more. I think this is not enough. So I will use level of detail 7 and change source type to circle, and select object field again, glass bottle proxy, and let's see how much we will get now. Yes, 2515 particles now. I think it's okay. Now we can settle the particles in the container. Click on hold time button. This is used to settle down liquids in the containers. After the particles settled down, we will have an extra volume on top of this container. So let's click on this. These two buttons don't do the same job. Hold time button calculates the simulation, but it does not create keyframes on the timeline. So we can use it to settle down the liquids in the closed containers. I think 15 frames is okay. Yes, now I can stop the calculation. After that, I can calculate the simulation now, and let's see what happens to the liquid in the bottle. To start the calculation and creating keyframes on the timeline, I will use this button, and this is equal to go button here. So let's calculate it. Yes, here is the first simulation. I calculated a 16 frame simulation, and let's see what happens. As you can see, some of the particles are passing through the walls of the container and going out. Let's find why this happens, and let's go back to Glu3D Object Manager. Before filling the container, we set these parameters to 0, bounce and adherence parameters. Before starting the simulation, I forget to change this bounce parameter to 50 again, and I have to set this collision gap to 0.2. These two parameters keeps the particles inside the container. If we reduce the collision gap and the bounce parameters too much, in a simulation fast particles can pass through the walls and they can go out. So now let's calculate the simulation again. Now I will flash the particle memory, but I will not delete the first frame. I mean the settled particles. I will not delete the settled particles. To do this, I will click on this glue icon and I will set this parameter keep until frame to 0, and I will click on flash particle cache. This will delete all keyframes, but it will keep the keyframe on frame 0. So let's flash it. Yes. And restart the calculation. This is the second simulation. Actually, I cancelled it in the second frame because I see particles are going out of the bottle, so I cancelled it. And let's see what's going wrong. Let's open the Glu3D object manager. I think this parameter collision gap value 0.2 is too much, and I'm changing it to 0.1. If collision gap value is too large, particles can act as they are exploding. So now I will recalculate it. So now I will recalculate it from the beginning, but before starting the calculation, I will flash the particle cache, and now let's calculate it again. Yes, this is our third calculation, and let's see what happens. Melon hits the ground, bounces, and moves. As we see, some particles are still moving out from the container. These particles are very high-speed particles, and for this subsample value, it is 1. The dynamic solver cannot calculate the collision of these particles with the container walls. So to keep them in container, I have to give a larger value, maybe 3 or 4, for the subsample parameter. But this time the calculation of the simulation will take a really long time, and time is money, so this means higher subsample values is very expensive. But if you have a really fast computer and extra time, you can use higher values like 3, 4, or maybe I will try to catch some particles inside that extra container. But I'm sure I cannot keep all particles inside by adding an extra container also. So these particles moving out of the bottle will act as the drops coming out from the melon after the first impact. I mean, when the melon hits the ground for the first time, here, I will use these particles and spare time. So this is cheating, and most of the times I do it instead of creating physically correct or perfect simulations. This is faster and cheaper. But if you are cheating, keep in mind that you have to find really good and reasonable explanations for that. In this case, I think drops coming out from the melon looks reasonable for me, and I hope it will work. Okay, now I will flash the memory. So let's select this icon, 0 flash particle cache, and I will make a copy of this object, and I will push the object very little, not too much, but a few larger, not too much. I think this is enough. And I have to add this object to object manager. Yes, it is already here. So let's close this and let's make a calculation again. Yes, now I have a 21 frame simulation. So let's see what happens. Melon hits the ground. Yes, a few particles are moving out, and some of them are moving out from the top also. Yes, I think this is a reasonable number, so we can use them as the drops coming out from the melon when it hits the ground. And these are meaningless, but I will control them later, so I will do nothing now for these. Okay, so now we can calculate all the animation from 0 to frame 220. So let's start calculating it. Yes, finally it has finished, and let's play the animation. I think it looks acceptable. Falls from the sky, hits the ground, we see particles going out. We will use them as splash drops. We will control these later. Second impact. Yes, and the fluid inside the bottle moves from one side to another, and I think it looks okay and acceptable. Now we can build the mesh around these particles. Let me change the camera view. I will click on this button to see the mesh around these particles. And yes, here's our mesh. But I will change some values of the parameters. Let's come to surface parameters. Surface level of detail, let's say 5, and drop size, I think 4 is too much, and let's say 3, and melting threshold 3, surface level of detail, let's say 8. Yes, I want a wavy look on the surface of the fluid. I want to see waves while the fluid moves one side to another. Let's try drop size 2. Well, it is too small, but maybe 2.5. Yes, maybe we can try this. Surface level of detail 5. Yes, maybe we can try this. Now, this is just an example. So, no surface is built in other frames. I have to build surface for all frames now, and I will click on build surface from the start of the playback range button, and it will start building surface from frame 0 to frame 220. So okay, let's go. Actually, this takes time also, but it is faster than the particle simulation. Last time particle simulation took about 2 hours to finish for these 220 frames, but I think this will take just 1 minute and 20 seconds. Now I will stop it. I just want to see the surface. I don't need these objects anymore, and I will hide them. Hide selection and hide selection, and let's use smooth and highlights. Yes. Let's see it closer. Now I will change some values. Let's change it melting threshold from 3 to 4. No, it is too smooth. And 3 to 3.5. Let's return back to 3 again, but surface level of detail to 10. No, I don't like it. Let's use 3.3 and surface level of detail to 20. This is a large number. And let's use drop size to 2.8. Yes, I think it looks good now. Okay, let's build the surface from the beginning. Sorry. First of all, I will flash the surface mesh cache, and I will build it again from the beginning. This took too much time. It is too small. It is too slow because I'm using surface level of detail 20. But actually, I think I can accept this model. It is not looking bad, I think. So now we can continue with the most difficult part. The most difficult part is the juice splash when the melon breaks into two pieces. We will continue with that. Yes, and here is the final animation of the bottle. Yes. Now let's see the peer wrapper and fill results in animation. Let's play it. Yes, these objects are created with peer wrapper, and you see the animation of fluid in the bottle. Okay, so now we can continue with the next chapter.